discuss thermal properties of matter. So we have been discussing the different types of properties of matter. Now this is the continuation of the same. Thermal properties. So when you hear the name thermal, it is something related to the heat. So in earlier days, long before, there was a concept about heat that it is a kind of fluid called caloric. A kind of fluid called caloric which is flowing through the object. If this fluid is added to a matter, the hotness of that matter is increasing. And if this particular fluid is removed from the matter, the body becomes cold. This was the concept we have taken earlier. But this concept failed in explaining many different thermal properties exhibited by the matter. So now we are depending on something called the kinetic theory concept. Based on kinetic theory, it is understood that the thermal state is defined by the kinetic energy of the molecules of the matter. The molecules can move along translatorily, can rotate, can vibrate. So based on this types of movement of the molecules, there can be kinetic energies associated with the molecules. So the total kinetic energy of all these types of motions of the molecules contribute to what you call the thermal state of the body. So heat energies depending on the kinetic energy of the molecules. Okay. Now the hotness is increasing as the heat is getting added to it. And the heat, when it is removed from the body, it is getting cooled. So this hotness or coldness is what we call temperature. So we can define temperature as degree of hotness or coldness of the body. Now this hotness or coldness of the body is only a relative concept, just because when you touch the body and you feel hot, it's because the heat or the temperature or the hotness of the body is greater than your body temperature. Instead, if you touch a block of ice, you feel coldness because your body temperature is higher than the temperature of the ice. So that's why I said it is a relative statement. So when a hot body and a cold body are kept in contact, suppose I say this is a hot body and this is a cold body. So they are in contact. When the hot and cold bodies are kept in contact, the heat will be flowing from, or something which is flowing from, energy is flowing from hot body to cold body. So heat can be taken as the energy which flows from one body to another body because of the temperature difference between the bodies. It's a general statement. Okay? Energy form which flows from hot body to cold body because of the temperature difference of the bodies when they are in contact. Okay? Now we started with the older concept what we call caloric. Now we are not using it, but still you will be coming across the name chlorine. calorie. This is taken as the unit of heat energy still. When we express the heat energy in terms of Celsius system, there comes the calorie as the unit for heat energy. So what is 1 calorie? It is the heat energy required to raise the temperature of 1 gram of water to 1 degree Celsius. So this is the basic definition given for 1 calorie. 1 calorie equal to the heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. Okay? But in solving problems and all, you will come across a situation there you want to connect calorie with the joule. So, there is a relationship between calorie and joule that 1 calorie is equal to 4.18 joules. Okay? This is the relation you are getting, and this relation is obtained from a quantity called joules mechanical equivalent of heat. Once again, joules mechanical equivalent of heat energy. So that is connecting with the mechanical work relate with what? Heat produced. Always you can see when we do a mechanical work on a system, that is indirectly producing what you call heat energy. For example, if you stir a cup of water continuously for a long time, you can see that the temperature of water is increasing. Another thing, suppose you take a metal block and hammer it continuously. You can see that the shape of that sheet will be changing, along with there is an increasing temperature of the metallic sheet. That means the heat energy is getting added to it. So, in all the case, whenever there is a mechanical work, there is a heat energy added to it. So, relating these two, we can say 4.18 joules of mechanical work, 4.18 joules of mechanical work can produce 1 calorie of heat. So, that particular quantity is represented by J, which is equal to 4.18 joules per calorie. So this quantity is called mechanical equivalent of heat. So in this session, you might have understood what temperature, what heat energy, what calorie, and the definitions of this. So keep these things in your mind while we go on with the properties of heat or thermal properties of matter. There are more things to be studied, and in all those parts, these quantities will be coming directly or these names are coming or used directly or indirectly. Okay?